All right, next up we have section 5.2, which is angle, side, angle, triangle congruence. So that's what ASA stands for, angle, side, angle. It's basically a shortcut to what we talked about in 5.1, because in 5.1 we had to show that all three sets of sides and all three sets of angles were congruent to one another between the two triangles. Well, this is a shortcut. This shortcut we can use to prove triangles are congruent using only two angles and the included side. So we'll decide if two triangles are congruent using angle, side, angle, and then we'll use angle, side, angle in proofs, and then I'm also going to link a construction so you guys can watch that and see why angle, side, angle works. So here's the angle, side, angle, triangle congruence theorem. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, we know those two triangles are congruent to one another. So here we have our two triangles, triangle ABC and triangle DEF. So if angle A is congruent to angle D, angle C is congruent to angle F, and then last we have to have the included side. So what I mean by included side is it's the side connecting the two angles you know are congruent. So in this case we're using angle A and angle C. So the included side would be angle AC because that's the side that connects those two angles. Same with this triangle. The included side would be DF because that's the one that connects the two angles we know about. So if we know this is true between the two triangles, angle A congruent to angle D, AC congruent to DF, and angle C congruent to angle F, we know triangle ABC will be congruent to triangle DEF. There's a website linked on Canvas right underneath this video that you can go and you can watch the construction for angle, side, angle, and you can kind of see the proof as to why angle, side, angle works, why, if you know angle, side, angle, why you know the two triangles have to be congruent to one another. So go ahead, take a little break from this lesson and go to that website and investigate that a little bit. All right, we are going to do an example. We're going to determine whether the triangles are congruent using this new shortcut, angle, side, angle. All right, so let's see here. We have this 45-degree angle, we have the 61-degree angle, and we have this side that has a length of 2.3 centimeters. In this triangle, we have the 74-degree angle, the 61-degree angle, and then we don't know angle D yet, but we can easily solve it. So let's go ahead and do that. The measure of angle D is going to be equal to 180 minus the two other angles. So minus 74, minus 61, and we do get 45 degrees. All right, so let's check here. We have angle A is congruent to angle D. Those are both the 45-degree angles. We have angle C is congruent to angle F because those are both the 61-degree angles. And then you can see that the included sides are congruent. Side AC is congruent to side DF. So you can see we have angle, the included side, and another angle. So our answer would be yes. Triangle ABC is congruent to triangle DEF by the angle, side, angle theorem. So see how it's a shortcut? We didn't even talk about B and E. We didn't talk about sides A, B, B, C, D, E, E, F. We just talked about angle, side, angle. All right, let's check this one. So we know we have the 31-degree angles, right? Angle J is congruent to angle M because they're both 31 degrees. We have these sides are congruent. JL is congruent to MP because they're both 62 inches. So now we just got to check angle L and angle P. So let's figure out what angle P is. We know angle L is 110, and the measure of angle P should be equal to 180 minus 38 minus 31. And that gives us what? This is 69, so that gives us 111. So angle P is 111 degrees. So we can see here angle L is not congruent to angle P, And therefore, our answer would be no, the triangles are not congruent because we do not have angle side angle. So for our first proof, we're going to try and prove that these two triangles are congruent using angle side angle. We're given the fact that MQP, that's this angle here, is congruent to NPQ. So let's go ahead and write that in for step 1. Angle MQP is congruent to angle NPQ. That was given to us. We are also told that MPQ, that's this guy here, is congruent to NQP. So let's go ahead and write that in. Also given. So we need one more piece of information. We got the angle, we got the other angle. So let's look at the included side. So this guy would be the included side. And you can see the two triangles actually share that side. So whenever your triangles share a side, we obviously know that that side is congruent to itself. PQ is congruent to itself. It's the same thing. That's the reflexive property. When anything is congruent to itself, you guys are using the reflexive property. So now we can see we have angle side angle. That's enough information to go ahead and say triangle MQP is congruent to triangle NPQ. And we just used the angle side angle theorem to prove that. All right, let's do another proof. In this one, we have these two triangles. We're going to try and prove that they are congruent. So first, we're given the fact that angle A is congruent to angle C. That was given to us. And notice how I'm always drawing on my pictures. That always kind of helps me see what's going on. So make sure you're drawing your given info. 2, we're told E is the midpoint of AC. Okay, so E is the midpoint of AC. That was also given. So let's go ahead and use this second piece of information. If E is the midpoint of AC, I know that these two segments are equal to one another. I know the segment from A to E is congruent to the segment from C to E just because of the definition of what a midpoint is. If it's the midpoint, it splits it into 2 equal parts. Okay. Next step, if you notice here, we got some vertical angles. Whenever you see this little bow tie shape, you got vertical angles here. So I know that angle AEB is congruent to angle CED because of the vertical angles theorem. Now from my picture, you guys can see we've just said all the stuff for angle side angle. Also, just a side note about step 4, don't call both of these angle E. Okay, they're 2 different angles, so you guys have to use 3 letters to name them. Okay, can't call both of them angle E. So make sure you guys are using 3 letters. Now we can go ahead and say triangle ABE is congruent to triangle CDE because of the angle side angle theorem. Looking at our picture, we got angle, we got the included side, and we got the other angle. So we've just shown that we have 2 angles and the included side are congruent between these 2 triangles, which means the triangles themselves are congruent to one another. All right, last proof, we are going to prove that these 2 triangles are congruent to one another. First, we are given the fact that angle S is congruent to angle U. So let's go ahead and draw that in. S and U are congruent. That was given. We are also told that RV bisects SU. That was also given to us. So let's go ahead and use that second piece of given information. RV bisects SU. Well, if RV bisects SU, we know that it chops it in half. So let's go ahead and say that. I know ST has to be congruent to UT because of the definition of bisect. If it bisects it, it's being chopped in half. You can see in this proof as well that we got two vertical angles, so we can go ahead and say that angle RTS is congruent to angle, oh no, a little lag here, angle VTU, because of the vertical angles theorem. And now you can see we have enough information to prove the triangles are congruent. Looking at my picture, I have angle, side angle. So I can go ahead and say triangle RST is congruent to triangle VTU by our shortcut, the angle side angle theorem. Okay, we're trying to prove that angle R is congruent to angle V. Well, I just said the two triangles were congruent, so since I know the two triangles are congruent, I know all of their pieces are congruent. So after step 5, saying my two triangles are equal, now I can go ahead and say angle R has to be congruent to angle V. Using that reason that we learned back in lesson 3.3, CP-CFC, corresponding parts of congruent figures are congruent. So I'm just going to change the F to a T, CP-CTC. T stands for triangle. Corresponding parts of congruent triangles are congruent. Since I said my triangles were congruent in step 5, in step 6 I can say any of their parts are congruent using CP-CTC. All right, now you guys have the 5.2 homework on HMH, so let me know if you guys have any questions.